one-sided limits. Okay, a limit exists if and only if and only if the limit from the left matches the limit from the right, meaning, or in math speak, that is, LIM as x approaches c from the negative side of f of x equals the limit as x approaches c from the positive side of f of x. I would memorize this right here. That is when a limit exists. And right here, this front part is approaching from the left. Left, or the negative side. Here is approaching from the right. Or the positive side. Moving to example 1. All right. Alright, I'm going to have the limit as x approaches 2 from the positive side of the square root of 4 minus x squared. Okay, first off, if I plug in 2 to that, even though we're talking about 2 from the right, I may get 0. If I plug in positive 2, 2 squared is 4. 4 minus 4 is 0. The square root of 0 is 0. Can y'all follow me? Well, let's take a look at this. Let's actually look at the graph of this. So, I have what this is, and you may not remember, is it's actually a graph of a semicircle, okay? So, I have negative 2 here, and sorry, this should be negative 2 that we're looking at. Limit as x approaches negative 2 from the positive side. Positive 2 here also. Since this value right here is 4, that particular value, that means my radius of my semicircle is 2. So now I'm going to draw myself what looks somewhat like a semicircle. Okay. Well, and it intersects the y-axis at negative 2 and 2. Okay. So what we want to find is the limit as x approaches negative 2 from the positive side. So what we're looking at is we're actually looking at right here, when the limit approaches negative 2 from the positive side. Okay, so what y value is that approaching right there? What y value is that approaching? Well, it's approaching 0. So again, that is my limit. So my limit equals 0. Now what if I asked you for the limit as x approaches to negative 2 from the negative side of the square root of 4 minus x squared? Well, let's look at this again. What value is it approaching right here? Well, it's approaching nothing. There is no y value. So the limit here does not exist. So I just technically couldn't plug 2 in there and say the limit is 0. In this case, I actually had to look at the graph. Okay? You have to think about some of these. This equation might be a good one to know, just to know that that means a semicircle if you have a perfect square there. Okay, now we're going to look at limits involving absolute values. So the limit as x approaches 2 from the positive side of the absolute value of x minus 2 divided by x minus 2. Well, the first thing I have to do is I have to take that absolute value and make a piecewise function. So x minus 2, well, does everybody remember what absolute value does? Oh yeah, it makes the number that's inside of it positive. So we're going to make a piecewise function. So we're going to say the absolute value of x minus 2 is of the negative. Well, first off, look at this. What value makes that absolute value negative? Yeah, you all guessed it. Anything less than 2. Alright? So on anything less than 2, now I'm going to have two bounds since 2 is my limit. It is 0 at 2. So my bound is going to be x can be less than 2 and x can be greater than or equal to 2. Well, the first thing I want to note in absolute value makes something positive, correct? So if it's negative, if my value is negative, I need to multiply it by another negative. So that's going to be the top part of my equation, negative of x minus 2. Okay, now on the bottom equation is x minus 2. Okay, so if I plug this in, again, we are looking at the limit from the right, so coming from the positive side. That means I'm going to use x minus 2 in that top part of my equation. Again, I'm going to substitute the x minus 2 from my piecewise function in for the absolute value, since I am coming from the positive side. So, the limit as x approaches 2 from the positive side of x minus 2 on top, and again x minus 2 on bottom. See anything that will cancel? Well, yes, it will cancel. And my limit as x approaches 2 from the positive side equals 1. Okay? Well, what if I asked you for the limit as x approaches 2 from the negative side? Well, in that case, of the absolute value of x minus 2 over x minus 2, what would I plug in for my absolute value? I'll plug in the top part, okay, because it's coming from the negative side. It's coming from when x is less than 2. So I'm going to stick in, and again, always rewrite my limit. Of the negative of x minus 2 over x minus 2. Again, my x minus 2's cancel, but I'm still left with that negative sign. Well, those cancel and get me 1. Or it's something divided by itself, and that is always 1. So that gets me negative 1 is my limit. Okay? So if we notice, if I were to actually sketch a graph of this actual function, because when you're finding limits, you're just finding the graph. If I went over to positive 2, well, anything greater than positive 2, well, my limit is 1. So draw a line at 1. Anything less than positive 2 is going to be negative 1. Okay? So, and that is actually just a good graph to know, because on your test next week, I could give you x minus 5, the absolute value of x minus 5 over x minus 5. Okay, one more. Find the limit as x approaches 1 of f of x, where f of x equals x cubed plus 1, x plus 1, x less than 1, x less than or equal to 1. Okay. Now I want to know the limit as x approaches 1. So, again, if I want to know a limit, the limit from the left must match the limit from the right. Therefore, I'm going to find both limits. So the first thing I have to find is the limit as x approaches 1 from the negative side. Then I have to go back and find the limit as x approaches 1 from the positive side. So coming from the negative side, that means I want less than 1, right? Slightly less than 1. So in this case, I'm going to use x cubed plus 1. On this case, we're going to stick in 1. So 1 cubed plus 1. 1 plus 1 is 2. Here, let's go from the right. The limit as x approaches 1 from the positive side is x plus 1. Again, stick in a 1. So 1 plus 1 is, again, 2. My limits match. Therefore, the limit as x approaches 1 of f of x equals 2.